Putting together a large-scale engine might be more complex than it's ever been. Design engineers have a variety of factors to consider, from fuel consumption to noise to, of course, reducing emissions. Technology is always changing, and so are supply chains. And it's all going on amid the backdrop of an ongoing pandemic that could change the way we do business forever. Sometimes, though, answers can be found in what might seem like the most unlikely places. Hi, I'm Phil Irvin, Content Marketing Manager here at Horton, and thanks for joining us today to talk about viscous cooling technology, specifically variable speed fan drives, and how they can make a world of difference for on and off highway applications. We will be checking in with cooling experts from around the globe to talk about how this technology helps with emissions and reducing noise and also maximizing performance and efficiency. Really appreciate you taking some time to join us today. We know it's been a crazy year. Somehow we're already into February of 2021. And we know you've all been impacted by the pandemic in some way, shape, or form. Our thoughts and prayers are with you, and we look forward to seeing a lot of you in person sooner rather than later. In the meantime, though, we appreciate you joining us virtually to talk about this advanced cooling technology. Here's a little more about how it works. Well, pleased to be joined now by Horton's two product managers. On the on-highway side, we've got Mr. Matt Stahl, and then next to him, Chad Nibelink, who works in off-highway. Gentlemen, thank you for taking a couple minutes with us today.
Thanks for having us.
It's great to be here.
Really appreciate it. We're going to throw the first question today to Matt, and it's a softball for you, Matt. For viewers who need a refresher, what exactly is viscous technology?
Sure. We'll start off with the basics. So the viscous technology we're talking about today is used in variable speed fan drives. Variable speed fan drives can control the fan to the precise speed required for the engine cooling.
Okay, simple enough. A little more detail on that, Chad. How does taking that viscous technology and applying it to turning a fan help with cooling an engine?
Yeah, well, viscous technology, allows the engine control unit to really precisely control the speed of this fan, all the way from full off to its maximum speed. It's kind of like how a dimmer switch on a light bulb allows you to adjust the amount of brightness you're getting out of your bulb for any given condition. Because the fan speed's always running at the exact cooling requirement of the engine load and your ambient conditions, you're not wasting energy by spinning your fan too fast. In colder climates like we have outdoors today in Minnesota, it also can limit your fan speed so you're not overcooling your engine. And lastly, it can really make your diesel particle filter regeneration cycles more efficient by limiting your fan speed during that time, allowing your engine to come up to temp and burning things off much more quickly.
And that's kind of the beauty of it, and that's a lot of what we're going to be talking about today. Is it does a lot more than just cool the engine, which is awesome. So not necessarily a new technology, but newer depending where you are on the globe. So how prevalent is it, both here in North America as opposed to, say Europe and other markets?
Yeah, that's a great question. Actually, in Europe, this technology has been around for decades. It was originally used in the automotive segment, and then right around the turn of the century, early 2000s, the off-highway segment became aware of the advantage of direct sensing viscous technology. So over there, it's been used for 2-3 decades or more. It's a very proven and very developed technology.
Sure.
Yeah, for North America, there's been sporadic use over the years, but we're starting to see some increasing adoption by the OEMs, especially as they drive to increase their efficiency and reliability of the engines, and also as they are working to meet the increasing emissions regulations.
Sure. Let's talk about trucks a little more specifically. What benefits does variable speed technology provide both for long haul and vocational vehicles?
Yeah, the truck market in general, there's 3 main benefits that I like to talk about: drivability, increased efficiency, and reduction in total cost of ownership. Drivability is improved just as the variable speed fan drive provides a nice smooth fan control. So it gets rid of those noisy, often harsh engagements that you get with an on-off fan drive. And also, a lot of the truck drivers out there know that you'll get those power-robbing fan engagements right when you need them, when you need that extra power. The efficiency side, like the OEMs can increase their engines' efficiency through calibration optimizations on their engine and transmission, and they can also program their truck's ECM to control the fan speed to the precise speed needed. For the total cost of ownership side, there's a reduction in downtime due to not needing any fan drive maintenance through the life of the truck, and Horton's LCX and RCX fan drives have been engineered and validated to be maintenance-free.
Sure. So what does all that mean for the aftermarket and the parts world now as we're going to see this kind of shift in technology over the next 5, 10, however many years?
Yeah, I think for the European market, they've already it's been widely adopted. So there's going to be nothing new there. I think the main takeaway for that is that Horton has a market-leading LCX, RCX drives available for their market. North America, there's going to be education will be key, especially for the drivers. Those drivers that have often had questions around, hey, is this fan drive even working? I don't notice engaging anymore. And that's going to be the beauty about this improved drivability piece of it. It's also a noticeable change for the truck drivers. You're really in tune with your truck. You'll notice those harsh on-off engagements, but with the variable speed fan drive, you don't notice them anymore, and it can be perceived as the fan drive's not working when it's actually working completely as intended.
Sure. And it's a good tease for education. There will be plenty more educational opportunities that Horton will be presenting after this, and we'll talk a little more about that in a little bit. But let's switch to the off-highway side of things with Chad. How does viscous cooling impact, your markets like construction, ag, mining, some of those off-highway big machines, for example?
First of all the benefits that Matt mentioned are key benefits for the off-highway market as well, but there's 2 kind of unique use cases for off-highway that viscous fans directly address. Now, first of all, a lot of these job sites are subject to really stringent noise regulations, and if you look at the amount of noise a fan generates, it goes up exponentially with the speed of the fan. So by having viscous technology and being able to precisely control your fan speed related to cooling requirements, you're able to back off the speed of your fan 10-20% in some instances, and that dramatically reduces the amount of noise generated by your vehicle, which is a tremendous benefit for a lot of the off-highway segments. Second, when you look at the use cases of off-highway vehicles, they're a lot more variable than some on-highway products. A great example would be like a dump truck in a mine. You load it up at the bottom of a hill, it's got to climb up a steep grade fully loaded, engine's under max power, it dumps, coast back down the hill. Or think of like an excavator where it has to pivot, fill up a huge scoop, lift it, dump it. The amount of power required throughout that cycle varies dramatically. A viscous drive allows your fan to instantaneously adjust and meet the cooling requirements by the vehicle, and that does two things. It increases your efficiency, so you're not burning fuel, spinning a huge fan at full speed all the time. And also in some instances, it can increase the productivity of your vehicle because you're not using energy that could otherwise be used to drive the vehicle for what it's supposed to be doing.
Absolutely. Well, if you couldn't tell already, these guys really do have their finger on the pulse of where technology's at today and where it's going. So that's what I'd like to close with both of you is, you know, we've talked about a little bit where we're at today, where we're going to be moving forward, but what does the future look like? You know, there's a lot of change going on with technology, economy, markets, there's the pandemic. We've got a lot of variables kind of playing into the situation right now. In terms of cooling and where things are going, what does the future look like?
Yeah, for the truck market, between now and the zero emission vehicle phase, there'll be a lot of focus put on improving the efficiency of your diesel platforms. And the variable speed fan drive is going to be key for meeting those new increasing emissions regulations.
Absolutely. How about on the off-highway side, Chad?
Yeah, there's a lot of segments out there that are still either using basically no drives. And so as they become more aware of the benefits in noise, productivity, and efficiency that viscous drives handle, viscous drives would be a great thing to consider.
Fantastic. Well, thank you guys for dropping so much knowledge on us and our viewers today.
Yeah, thank you.
Thanks for having us.
Great. So we will dive a little deeper with a couple of Horton's application engineers, but they eat, sleep, and drink this stuff and breathe it every single day. But wanted to show you a little bit of a demonstration, more specifically on how viscous cooling technology works in action. So the animation you're about to see is a product that Matt mentioned. It's Horton's new LCX fan drive. It's basically Horton's newest viscous fan drive on the market, and it can be used in a variety of on and off highway applications. Let's have a look.
Presenting the LCX fan drive series with cold start disengagement from Horton. The main parts of the LCX viscous fan drive are the housing, rotor, reservoir, valve assembly, oil return pump, and oil release point. Viscous technology provides maximum fuel efficiency, more available horsepower, and lower noise as it delivers only the needed fan speed. Fan speed is controlled by adding or removing oil in the working area. Here you can see a cutaway view of the fan drive. The rotor and shaft spin at the input speed transmitted from the engine. The cover and housing provide the output fan speed. When the working area is full of oil, both spin at the same speed. The ECU controls the fan drive by sending signals to a valve that releases oil when opened. The oil is released through the valve into the working area and pumped back to the reservoir through the return pump. To achieve a very low off-fan speed, the fluid is pumped out of the working area and into the reservoir. To increase the speed of the fan drive, fluid is released from the reservoir into the working area, transmitting torque to spin the fan. Our cold start disengagement feature ensures that oil is held in the reservoir while the engine is off. This prevents unwanted fan speed during cold start. The result of this cold start disengagement feature is that the fan drive with CSD quickly disengages after startup, while the drive without CSD is still engaged when driving begins and can take up to 3 minutes to disengage. The benefits of our new LCX fan drives are obvious. It has an industry-leading low-speed controllability and off-speed, which provides precise fan speed control, maximum efficiency, and low noise. It has CSD for quieter engine starts and a quicker disengagement at startup. and our durable design ensures maximum uptime and long life.
Awesome. Well, I think I failed to mention, but I am sitting here in Horton's R&D facility in Roseville, Minnesota. For our next conversation, we are going to go to the other side of the globe to a place called Schweinfurt, Germany. Horton has a plant and offices over there, and yesterday I sat down with Konstantin Brunkwell, who is one of Horton's engine cooling experts, application engineers over in our German office. He was able to give some really good perspective on what viscous cooling technology means in the European and what we'll call some more advanced markets. Like Mats and Chad said, in Europe, what we're talking about today isn't new, but there are a couple new benefits and features that Konstantin and I talked about that you might find interesting, whether you're in North America or across the pond. Here goes that pre-recorded interview with Konstantin. All right, we are here online with Konstantin Brunkwell, application engineer for Horton, all the way in Schweinfurt, Germany. Konstantin, how are you? Thanks for joining us today.
I'm very good, thanks. How are you doing?
Not too bad. Talking before we came on, it's unseasonably cold in both the Twin Cities and Bavaria, but some beautiful snow on the ground, so we will take it. Well, for starters, Konstantin, tell us a little bit about your role and just what it means to be an application engineer.
I am basically responsible for selection and dimensioning of customer-specific applications regarding fan drives and fans here in Europe for on-highway customers.
Very good. Now, you're obviously have to be an expert in viscous cooling technology, which we're talking about today, because it's really nothing new in the European Union, used for the better part of the last 2 decades. Why has it been so widely adopted for engine cooling purposes specifically?
I think the mindset in European engineering is that you try to improve the efficiency, and the viscous clutch is something that helps a lot. The main advantage is that you can upkeep a constant fan speed and therefore also a constant engine temperature, which makes the engine work more efficiently. Yeah, and another good thing is you have advantages in noise pollution, and also that thing is maintenance free.
Yes, all things that are very prevalent in Europe and are starting to be and will continue to be here in the United States. Now, Horton's variable speed systems include something called cold start disengagement. What is that, and why is it useful?
That's a feature that helps to disengage the clutch quicker after a cold engine start, which also contributes to the whole noise pollution and fuel saving topic. Usually we at Horton, we call it feature. It's more like a characteristics that it engages quickly. But with the LCX and RCX clutches, we implemented this feature, which is kind of a special design in the interior that helps to improve that.
Absolutely. Fantastic. Last one for you. We recently created a new semi-automated state-of-the-art manufacturing line there in Schweinfurt, specifically to build these types of drives. Tell us a little more about that.
It's a compact line, very fast. I have to admit, it's way faster than I am with putting out 60 clutches an hour, which adds up to 80,000 pieces a year in one shift. So it's pretty much, to be honest. I like it very much. It is almost completely robotic controlled. So we have a lot of robot arms that manage quite well so far.
Awesome. Well, glad to hear it. Stay warm over there. Enjoy the rest of winter. And thank you for taking a couple minutes for us today, Constantine.
You are very welcome. Have a nice day.
You too. All right. If you want to learn a little more about the LCX, Horton's new RCX fan drive, which is very similar to the product you just saw displayed, and just more about this technology in general, you can visit hortonww.com/viscous. Also, please keep an eye on your inbox as well as Horton's social media channels in the coming days, as we will be putting together a webinar that dives deeper on this topic. But I'm very pleased now to be joined by another Horton application engineer. Cody Wenzel is right here in our Roseville, Minnesota offices, and he works primarily on the off-highway side of things. Cody, thanks for taking a couple minutes with us today.
Thanks for having me.
So to start, I want to just ask you kind of what goes into even being an application engineer. It's a big part of what we do here at Horton. Tell me a little more about your role and the team here that you're a part of as well.
Being an application engineer at Horton is somewhat of a unique position as far as application engineers go, even I think because we have to have such a well-rounded skill set.
Yeah.
We have to have such a, we wear a lot of hats basically. So we interface with sales directly, and we interface with the customer directly, so we have to have that customer service experience. But we also have to have a really good understanding of the product line first and foremost, and manufacturing, so we interface with manufacturing, the plants directly. So we're kind of almost that glue that kind of ties a lot of the departments together. So
yeah, absolutely. So we've talked a lot today about how viscous cooling technology is relatively new in the U.S. and Canada. How do you see that changing over the next 5 to 10 years and kind of into the future?
we've already kind of started to see it blow up a lot. It's growing pretty substantially, and off-highway and off-road markets tend to follow on-highway and on-road markets, and that applies to a lot of industry. And so they kind of on-highway kind of gets these new technologies in the door and familiarizes customers with them and familiarizes basically the market, the world with them. And then they also are usually kind of high volume, so they drive price down. So it seems to make it a little bit easier for off-highway to kind of dip into that. So, and customers, they find they want that after a period of time, after using it and experiencing it and seeing the benefits of it, then they kind of want it. So there's a number of benefits to viscous cooling technology, with emissions requirements and reduced noise, as a desirable thing, especially in like construction sites and whatnot. So viscous technology kind of is, it's just going to continue to grow, I think, over the next 5-10 years, and it's going to continue to replace direct drive fan options too, where we have like just a fan, and now all of a sudden it becomes a lot more easy to emerge into having that viscous clutch.
Yeah, absolutely. So what I love about talking to you application engineers is you're very good at taking kind of complex ideas like we're talking about today and sort of distilling it in ways that even like I can understand, which isn't always easy. So can you give us kind of the Cliff Notes version of how viscous and variable speed technology, it helps with a lot more than just temperatures. You're talking about noise, you mentioned emissions, performance, efficiency. Kind of dive into that a little bit in the way that only an application engineer, I think, can.
Well, sometimes I think we have to simplify it for ourselves so we can actually understand it too. But those are the big drivers. So you have your noise emissions is getting huge. It's like I said earlier, we have construction sites where a lot of times they're in residential development areas and whatnot, or even like downtown in large cities, and you need to be able to have that. You need to be able to have it under a certain limit, and a lot of cities have strict regulations of what that needs to be. So the viscous clutch helps reduce the fan speed, and then in turn helps reduce the noise. That's the same thing with emissions. So you have running less fan speed, running less fan, so you're going to have less power draw. And when you have less power draw, you have better fuel consumption, and then you also have less emissions. And then on the another side of that is a lot of our applications are diesel engines. So in fact, probably the overwhelming majority that I work with are diesel engines. So diesels have to run hot. I mean, they have to run within a certain temp and a certain load. So overcooling tends to cause a whole nother bunch of issues for diesels. And a lot of times, especially in our colder climates, when you're running a viscous clutch or you're running a cooling, you're just running a direct drive fan setup, you're going to overcool. So it really helps to have that viscous clutch to be able to slow that fan down so you're not overcooling, so you're just dialing in and cooling exactly where you need to be.
Sure.
Yeah.
So we'll let you go with this one. We would be remiss if we didn't mention the fans that these variable speed fan drives turn. What impact does fan design have on performance, emissions, and some of the other challenges we've been talking about today?
Yeah, so when we design and when we spec a new application, it always starts with a fan, because ultimately you need to have a fan that cools the engine properly. So even if sometimes we have applications where it's just a fan, and sometimes we have applications where we want a fan and a clutch. So either way, we start with the fan, and so it's the number one driver. So we have there's a number of things that come into play. The package size of the vehicle, what size fan we're actually going to need. We have the price. Price is always a big driver. There's certain situations where you wouldn't want to have, like, let's say, a fully molded plastic fan in like a mining situation. It just isn't durable enough with debris and rocks. So we need to be able to have, in that case, we'd spec an H-Tech, one of our thermoset composite blades, or a metal fan for the durability. So there's a number of factors that come into play, number of blades, and the weight of the fan, the price, and we always have to kind of find that fine balance sometimes of being able to find something that is within the power draw requirements of the customer, yet still fits the package size, yet still fits their price point, and it's just a constant balance. And fortunately, we have a lot of different fans to choose from and product lines to have that variability in choosing the right fan for the application.
Sure, absolutely. Well, fantastic. Thank you for taking a couple minutes with us today, Cody. Always appreciate your time.
Yeah, good to be here.
Awesome. That's going to do it for us. Before we let you go, want to learn more, have a question, feel free to drop us a comment. You can visit us at hortonww.com. Also check out hortonww.com/Viscous. Like I said, keep an eye out for a more in-depth kind of deep dive webinar on this topic. And be sure to subscribe to us on YouTube. You can like us on Facebook and LinkedIn. Always trying to continue to educate and inform in the areas of cooling, which, along with the rest of our industry, is changing, it seems like, every day. Thanks again. Stay safe, stay healthy. I'm Phil Irvin for Cody, Constantine, Matt, and Chad, and all of us here at Horton. Thank you very much for joining us.